Across our planet's vast agricultural landscapes, a monumental effort unfolds annually. In the United States alone, farmers cultivate nearly 900 million acres, yielding crops valued at over $170 billion, a powerful testament to the crucial task of feeding the world. This is the narrative of modern agriculture, a sphere where human ingenuity and technological mastery unite. Here, people and machines collaborate in a finely tuned orchestra, conducting harvests distinguished by their precision, productivity, and sustainability. Embark on a journey through some of the world's most extraordinary harvests, where every seed is nurtured by an agricultural system in a perpetual state of advancement. The unassuming red radish, while not as lucrative as other crops, serves a vital function in the agricultural cycle for Californian farmers. Its swift 30-day maturation period facilitates rapid field rotation. During harvest, laborers manually extract the radishes, choosing those that conform to a strict 2 to 3 centimeter standard, before bundling them for fresh markets. These cumbersome baskets are then transported to farmers' markets across the state. In striking contrast, contemporary greenhouses have almost completely automated the radish harvest. Specialized machines navigate the impeccably aligned rows with the aid of optical sensors. Parallel grippers hoist radish clusters of the ideal size, processing each in a matter of seconds. An auto-bundling mechanism then fastens every 10 roots with a nylon band, fashioning uniform bunches with mechanical precision. This system can handle an astonishing 1 ton of radishes per hour, diminishing the need for manual labor by over 80%. The sole remaining human responsibility is to transfer the completed bundles onto trays for washing and packaging. In Japan's Yamagata Prefecture, a singular delicacy materializes once a year: the snow-aged apple. As the Fuji apple season concludes in late December, the most select apples are hand-picked and conveyed to snow-laden mountains. Farmers meticulously stack them and employ snowblowers to submerge the fruit under 2 to 3 meters of snow, shielding them with wind-resistant tarps. By late March, as the snow recedes, the apples, dubbed Yuki Ringo, are unearthed. This 3-month hibernation tempers their acidity and elevates their natural sugars, cultivating a perfectly balanced, crisp flavor with a honey-like scent. These premium snow apples fetch a higher price and are frequently utilized for fresh juice and desserts. In North America, the highbush blueberry, accounting for 80% of global blueberry production, is ideally suited for extensive mechanical harvesting, thanks to its synchronized fruiting. The Oxbow 7440, a veritable behemoth of the fields, boasts a tunnel frame that glides over the tall bushes. Internally, a dual-shaft shaking system evaluates plant density and fruit ripeness, modifying its vibration to optimize efficiency and reduce bruising. Its top-loader system has a capacity of up to 400 kilograms, enabling uninterrupted operation. For the wild low-bush blueberries of Maine, which flourish in dense, low-lying mats, the grasshopper harvester is custom-designed. Its mechanical comb, fitted with delicate steel tines, is calibrated to skim only the uppermost layer of the bushes, where the ripest fruit is found. This exactitude averts damage to the plant and guarantees the lower foliage is preserved for subsequent growth, safeguarding the heritage of these ancient wild landscapes. In Vermont, the age-old practice of gathering maple sap in buckets has been superseded by a modern, streamlined system. From February to April, workers bore small apertures into the maple trees and link them to an expansive network of tubing that spans kilometers of forest. This enclosed system, augmented by vacuum pumps, conveys the sap to a central collection point, decreasing manual labor by up to 80% and maintaining the sap's integrity. The sap is subsequently filtered and boiled down to produce the iconic amber maple syrup, with Grade A varieties commanding prices as high as $250 per gallon. Brazil, the global leader in sugarcane production, harvests approximately 650 million tons each year. Historically, fields were incinerated to clear leaves and simplify manual cutting. However, owing to environmental considerations, Brazil has largely transitioned to mechanized green cane harvesting. Specialized machines now sever the cane at its base while concurrently stripping leaves and tops. The stalks are promptly ferried to mills, as any holdup can lead to a steep decline in sugar content. Making up the other 20% of the world's sugar supply, sugar beets are harvested from September to November in Europe, Russia, and the northern United States. Enormous, self-propelled harvesters delicately extract the beets from the earth. Spinning knives then shear off the green tops, which are left behind as a natural fertilizer.
The beets undergo cleaning by a sequence of rollers and turbines before being stored in a capacious holding tank. Though traditionally linked with Japan, wasabi is now cultivated throughout the year in North American greenhouses under meticulously regulated conditions. Grown on dry gravel beds with a top-down drip irrigation system, this technique curtails fungal diseases. At harvest, workers employ small shovels to unearth the plants, prune the leaves and roots, and tenderly rinse the rhizomes to safeguard the thin, fragrant skin that imparts its characteristic pungency. This greenhouse approach yields lower rates of rot and consistent quality. The custard apple, a high-end fruit for American consumers, demands exceptionally gentle handling. The cardinal rule of its harvest is support first, cut second. Adept pickers cradle the fruit and sever the stem, leaving a small segment attached to shield the skin. The slightest compression can mar the soft, segmented flesh, rendering the picker's precision more precious than their speed. Bamboo shoots must be gathered at the opportune moment, as a delay of even a few days will render the tender sprouts fibrous and unpalatable. Harvesters scan for minute indicators in the soil, such as a slight elevation or a fine fissure, to pinpoint the subterranean shoots. They then use a sharp knife to carefully excavate and cut the edible section, leaving the roots undisturbed for subsequent growth. In Kerala, India, the harvesting of palm fruit necessitates ascending towering trees that can reach heights of up to 35 meters. Some farmers ascend the trunks with their bare hands, while others utilize support ropes. Wielding long, curved knives, they slice through the substantial stems, taking care not to damage the translucent fruit within. The blue agave, the key ingredient in tequila, matures over 7 to 9 years in the highlands of Jalisco, Mexico. Upon reaching maturity, skilled humidores prune the sturdy outer leaves to reveal the plant's core, or piña. Using a sharp, circular steel blade affixed to a long wooden handle known as a koa, they sever the roots and lever the dense core from the earth. An experienced humidor can harvest a fully grown agave, which can weigh as much as 100 kilograms, in less than a minute, their toil laying the groundwork for every bottle of tequila. Illinois, the pumpkin capital of the United States, witnesses its fields spring to life from late September to November. Harvesters for fresh pumpkins employ sharp blades to sever the stems and mechanical arms to hoist the pumpkins onto conveyor belts, where rotating brushes eliminate soil. For pumpkin seeds, specialized machines pulverize the fruit in the field, isolating the seeds and returning the rind and flesh to the soil as organic fertilizer. These integrated technologies enable American farmers to satisfy the immense holiday demand,
and yield over 680,000 metric tons annually. Modern cotton harvesters have transformed the industry, reducing costs through on-field process optimization. Rotating drums utilize a suction and brush mechanism to delicately detach the cotton fibers. A pneumatic system then expels debris. The machine's most remarkable attribute is its automatic module builder, which compresses and encases the cotton into dense rolls while the harvester remains in motion, substantially diminishing handling and fuel consumption. With a projected global harvest of over 190 million tons in the 2025 season, tomatoes are one of the world's most extensively cultivated crops. Tomatoes destined for the fresh market are hand-picked to preserve their fragile skin. In contrast, processing tomatoes are gathered by self-propelled machines that cut the entire plant and employ an onboard system to strip away vines and leaves. Advanced optical sorters then differentiate the ripe, red fruit, and a single harvester can amass up to 60 tons per hour. Cranberries are harvested via a distinctive wet harvesting technique. Farmers inundate the bogs and utilize water reels to dislodge the berries from the vines. The cranberries ascend to the surface due to minute air pockets, forming a breathtaking crimson expanse. Conveyor harvesters then traverse the flooded bog, scooping up the floating berries, draining the water, and depositing them into boats or bins. In the Flanders region of Belgium, the Brussels sprout harvest is dependent on specialized machinery. These harvesters employ 6 rapidly rotating blades that trim the compact sprouts from the stalk, processing one plant every 6 seconds. Fans and filters cleanse the sprouts before they are deposited into a collection hopper. This high degree of mechanization allows Belgian farmers to harvest over 156 million pounds annually. Kale is harvested in 2 distinct fashions. On small farms, workers manually strip the fresh, curly leaves from the stem.
For industrial processing, mechanized harvesters use high-speed cutter bars to remove all the leaves in a single sweep. The leaves are then chopped and transported by a conveyor into an adjacent trailer, with both vehicles synchronized by GPS for uninterrupted operation. This mechanically harvested kale is earmarked for products such as chopped frozen kale. Despite progress in automation, pineapple harvesting in Costa Rica continues to be a manual and arduous task. Workers navigate between rows of sharp-leaved plants, shouldering heavy traditional baskets. The human factor is indispensable for ensuring each fruit is flawlessly shaped and intact. To enhance efficiency, moving conveyor belts are employed. Farmers place the detached pineapples directly onto the belt, which ferries them to collection bins, thereby reducing bruising and saving labor. In California, which accounts for over 99% of America's walnuts, the harvest commences when the outer green husk splits open. Hydraulic tree shakers clutch the trunks and exert up to 3,000 pounds of force, causing the nuts to cascade down in under 10 seconds. Sweepers then consolidate the fallen nuts into rows to be vacuumed up and dispatched to drying facilities. The cashew harvest represents another domain where mechanization has proven difficult. The nut's shell harbors a highly corrosive acid oil. Farmers gather the fallen cashew apples by hand and skillfully extract the nut. This manual dexterity is essential to avert oil leakage, which can cause skin burns and contaminate the nuts. Human hands persist as the most dependable tool for this intricate task. Along the shores of Lake Michigan, farmers utilize low harvesting carts to slowly progress through fields of green asparagus. Workers meticulously cut each spear when it attains the ideal length of 18 to 22 centimeters and place them in trays. The asparagus is then transported to processing facilities within 4 hours to preserve its freshness. In California's garlic fields, colossal self-propelled harvesters unearth the bulbs from the sun-scorched soil. Vibrating conveyors and fans eliminate soil and dried leaves, and tons of garlic are funneled directly into waiting trucks. Nevertheless,
On small organic farms in Gilroy, garlic is still hand-pulled and left to dry in the sun, a homage to traditional practices. Rice transplanters, compact machines tailored for muddy paddy fields, have transformed rice cultivation. Their synchronized mechanical arms plant seedlings at precise intervals, supplanting the labor of over 30 workers and enhancing yields. At harvest time, combine harvesters, ranging from the compact Kubota models in Japan to the massive John Deere and New Holland machines in the US, efficiently cut, thresh, and separate the grain, facilitating a global rice production of over 750 million tons annually. In high-tech greenhouses, the future of agriculture has arrived. The Octinian Rubion robot harvests Gerbera daisies with its slender mechanical arms, which are outfitted with vision sensors and 3D cameras. It pinpoints flowers at their peak bloom and delicately twists and pulls the stem at a rate of 1 flower per second, up to 5 times faster than a human. Similarly, autonomous robotic arms equipped with multispectral AI cameras are starting to supplant human pickers on strawberry farms. These robots can ascertain ripeness by analyzing color and surface sheen, then gently pick the berries. Although the initial outlay is substantial, these machines signify a major stride towards fully automated, intelligent farming. From the skies, light transport helicopters have become indispensable for the Christmas tree harvest in Oregon's mountainous regions. Utilizing vertical reference flying, pilots can transport thousands of trees from hillsides to collection points in a mere fraction of the time required for ground transport, while also mitigating environmental impact. The Odyssey from seed to harvest is a compelling saga of human exertion and technological innovation. Around the globe, farmers persist in adapting and evolving, harnessing a symphony of skill and steel to nourish a burgeoning world, ensuring that the Earth's bounty graces our tables.